so we're given this expression, this Boolean expression. So a multiplied by b naught multiplied by a naught plus b, and that is multiplied by b naught plus b. So to do this question, you should have a series of equations, kind of like, not equations, but rules that are memorized. So when I first looked at this, the first one that came out to mind was this rule where b naught plus b is equal to 1. So immediately we can cancel this part of the expression out. So what we're left with is ab naught multiplied by a naught plus b. So we're kind of looking to break apart this part of the equation using the expression a times, this is more like the theorem, a times b plus c, which is then equal to a plus b plus a times c. So once we fit into this equation, I kind of just have it memorized, I guess. And it's a lot easier, saves a lot of time. You just memorize that once we have the a, b naught, and we're applying this rule, we automatically, that's not a z, that's an equal sign, a naught plus b naught. So now we're going to replace this by this. So we will have a naught plus b naught multiplied by a naught plus b. So now it's a lot easier because now we can distribute. So when we distribute, we get a naught times a naught multiplied by plus a naught b naught plus a naught b naught. This is our new equation. So just like this rule that we had written before applies right here. We have two a naughts. So the identity for the two a naughts are a in general. So if it's a times a, it's just a, or a naught, whichever one it is just going to be that value. So a or b multiplied by itself, if they're both a and a or both a naught, you're just getting a naught. So now let's just replace that new expression. So we're going to get a naught plus a naught b naught plus a naught b naught. This is the now new equation. This is more like a puzzle game. It's not really a set of rules that you can follow. You just look at the new expression and kind of see what you can simplify. So as soon as we get this equation, I see that all of them have a naught, which I can like pull out. So if I pull out a naught, I'm going to get 1 plus b naught. So if you look really closely, this part looks just like this. So now we can simplify it even further, and that just becomes same thing as 1. So this whole thing just becomes 1. So a naught times 1 is just a naught. So final solution of this entire expression, simplified, is a naught. And you know you got it correctly because you really couldn't simplify it any further. If you're left with like a naught plus a naught or just some kind of expression, you know you can go simpler, I guess. So yeah. Now the next equation, question. So we have a balanced 3-phase Y-connected source using a positive phase sequence of VAN is given to you as 120, angle 30, and they're asking you to find V, BN. So first thing is this is really important. Why is it not coming up yellow? Yellow. Awesome. All right. Balanced. So when the three-phase Y connected source is balanced, automatically this rule applies. So VAN is equal to, so the value of VBN minus VCN. So we're going to be applying this equation. So looking at the question itself, you can also notice that this VAN is positive. So basically what that entails is that VBN is lagging VAN because 120 is positive. So now that we kind of see that it's a positive lag, we know it's lagging by 120. We can just plug into the formula, this formula right here, in terms of VBN. So VBN is equal to VAN angle 30 minus, which we said was 120 degrees. So basically you just do this math equation right here, which is just 30 minus 120. The equation, I know like problem probably seems a lot more complicated than it is, but that's really what they're asking for. It is just what VBN is, and VBN, once we do that, is 120. So we just carry down the 120 volts, which is an angle 30 minus 120 is just negative 90 degrees VRMS. And this is what. And if you want me to draw, let me see if I can draw this out. Okay. So we have the three phases, and they're shaped like a Y. So let me actually do it like this. Doop, doop. Okay. So we're going to have VBN over here. This is VAN, which was what was given to us. And then this is VCN. 120, which is the 30 VRMS. And then what we solved for here was 120, negative 1, negative 90 VRMS. So yeah, this is kind of what the, I guess, if you were to draw it out, this is not the best Y, but so as you can see, VBN is lagging by the 120. This is 120 degrees. So yeah, that's the problem.